Okay, let us start the class. So, in the last class, I told you about the different types of sensors that are available for fingerprint, that is optical, silicon, ultrasound, and thermal. I told you that optical and silicon are inexpensive and they are generally very commonly available. But they have a lot of disadvantages that even though they are inexpensive and cheap, there are some disadvantages which are sorted out in ultrasound and thermal. Like, you have dirt, or you have you have dirt on your hands, or somebody else has put the fingerprint and that impression is still there. Or now, as I told you, we are now in this pandemic period. Somebody puts a fingerprint and that contact. For both optical and silicon, there is a need for contact, and that contact can be fatal. So those issues are there, which are completely avoided in ultrasound and thermal. But ultrasound and thermal are more expensive. That's the only problem, and they are not so widely seen. So today we are going to see the actual process of how the fingerprint recognition system works, the verification works. I already told you that in a fingerprint there are many features. These features we can also call them ridges, lines, or minutiae. There are different types: bifurcation, arch, loop, island, ellipse, tented arch, spiral, rod, and sweat gland. So these are various types of minutiae. And I also told you that based on the prominence or the dominance of a minutiae, we have the Henry system of classification, wherein 2/3 of all fingerprints are either right loop. The right loop and the left loop is the most prominent part of the fingerprint. 1/3 are whorls like this, something like concentric circles, and 5 to 10% will be arches or tented arches. Arches, you can see how it is like an arch, that is there. So that is the classification. Now, what actually happens in the image processing context with respect to a fingerprint system is, you have a fingerprint. That fingerprint is the image is acquired, and all the image processing applications or image processing constructs happen on that fingerprint, which includes cleaning up the image, pre-processing, extracting the features, registering the template in the database, and storing this template. Likewise, when you are doing it for the second time, the same fingerprint, the same process happens rather. The pre-processing, the feature extraction, and the and the storage of the new template, and this is compared with the earlier template that is already there in the database. So it's a very simple logic. The same logic is used even by most biometric systems. Now, in the fingerprint, what is actually happening is, as I mentioned, there you need to get a clear print. A clear image is needed. And obviously, when you give your image, you can see there is some dirt here. That is why it has come black here. If I just pointing out the cursor, those kind of issues are always there. So what we can do is, we need to do the image processing applications. We need to clean up the image, improve the quality of the image, and one way is in enhancement of the features. And we don't need unnecessary features, so we can make a threshold, and based on that threshold, all the features that are not so dark below the threshold you can ignore, and you can only focus on the features that are above a threshold, and thereby you get a very clear image like this. Now, this image, you can have different ways to convert it also. You can decide how many pixels per minute, those kind of approximations also you can do. In 1 pixel, how many minute should be there? Or you may have 5-6 pixels for 1 minute. Can you combine them and into a single pixel? All those kind of operations are there. But the moral of the story is that the image that is taken from the fingerprint is enhanced in terms of features, and you get a much clearer image. Once you get the clearer image, you do what is known as minute localization. Removing of all the false kind of minute that are not needed, dirt and all that you can remove. The minute are localized, the features are enhanced, and all these false minute are removed, and you are only taking the true minute which are very good. The image is good, the image is clear, it is above a threshold. And not only that, we are not only looking at the minute, the angle of the minute and the dimension of the minute in terms of an XY scale is also taken. So these are the operations that happen. Now, what you do is, how do you do this mapping, this matching, so as to speak? Now, there are two ways to do a matching. One matching is a correlation based matching. You have the first image that is there in the database. Now you have the second image that you have taken now, and you do a correlation. Yeah, I don't know, in between something went off. So you have the first image, you have the second image. Both the images are superimposed on top of each other. You take the first image, put the second image on top of it. Obviously, I do not need to tell you that it will fit like a glove, because it is the same person's thing. And you can even get a series of, you're getting, see how both are, this is the same person's image. You put this on top of this, you will get completely black, right? If it is a different person, you will get some sort of superimposed image that is garbled because of the fact that these are different people's fingerprints. This and this is identical. You put this on this, you get something like a blank, right? And if you put a different image on top of it, you may not get a blank. But then there are some issues on the placement of the finger is also very important. When you are doing correlation mapping, the placement. I don't know, some net connection problem is here. Anyway, okay. Now, when you are doing the correlation, you can also get some numbers. Obviously, when you see that 000 means it is the same image. Slight variations here and there could be there in some points. If you see this enrolling matching, whenever you say 0000, that means it is the same image. And you should get you should get perfect correlation. But as I mentioned, when you are taking your finger slightly, you are turning your finger to the right, these kind of correlations, some values here and there may be changing. But the simple logic is as simple as that. You have the first image, you put the second image on top of the first image, you should get something like this. And it will all be zero. The correlation, that coefficient, that number should be zero, because it is the same image. But you put in some angle and all, slight changes may come, but still those changes may not create much of a problem. I mean, still you may get the same image, result or outcome, but then you need to be very clear. Putting the placement of the finger is very important. The second thing is, there is a minute matching. So as I mentioned, this is the fingerprint, second fingerprint. You have the minute, you have removed all the false minute. This may be a ridge, this may be a pore, this may be a loop or whatever. And then you do a minute matching from the first image, to the second image. This is the another method of doing a fingerprint matching. So each minute is mapped to the other minutiae, and based on that we are able to decide. And obviously when the minutiae are matching, you know that it is the same fingerprint. So these are the two methods. One is superimposing, putting the first image on top of the second image on top of the first image and looking at the correlation. You should get a blank dark image like this because it is the same image, and you should get zero values. Or you take one minutiae at a time and compare the minutiae of this image to the second image. So these are the two methods for fingerprint. Now in fingerprint systems nowadays, many criminal databases and all, there is an automated kind of fingerprint recognition system is there. So automated fingerprint systems are used by law and police enforcement agencies all over the world. So you get some crime scene, the crime scene, there is a partial print or a complete print. You take that image and that image scans through thousands of the images of known criminals and their fingerprints. That is why the first thing that they do is when a crime is reported and the culprit or not the culprit, I would say that the person who's suspected of creating a crime, they do not wait. They just take the fingerprint. Whether you have committed the crime or not, or you are accused of the crime, they still take the fingerprint so that the database is created. And that database, if you see, the database is created and it is automatically searching. So from a crime scene, you get a partial fingerprint or a full fingerprint. You take that fingerprint despite the inefficiency or the partial nature or the it is able to quickly scan through the database of and look for criminals. And that is the heart of this automated fingerprint identification system. And that way you are able to this thing. Now the biggest problem in India is that, see, India is a federal structure. Federal structure means there is a state government. There are, 25 to 27 states are there, union territories are there. There is a separate state government and a federal government or a central government. And obviously there are agencies. There are many of the agencies are common. There are central agencies. There are state agencies. It's a nightmare in terms of this kind of issues, because there are, so the state will say that it should come under the state. The central government will say that it should come under us. And many things are what is known as a concurrent list. If you say law and order, police, law and order is on the concurrent list. That means the state government has to take cognizance. The central government also has to take cognizance. Defense is not on the state government list. It is on the central government list. So you can imagine all the defense agencies are all central agencies. Police agencies are both central and state. You can see the major problem. There are 30 plus intelligence agencies in this country. I'm not counting the state government, but 30 plus central agencies are there. Revenue, intelligence, military. Oh, sorry. I don't know what is the problem here. Yeah. So you can imagine the nightmare that is there in terms of these agencies. So now, of course, the government of India is planning on what is known as a national intelligence grid, wherein every single database will be connected. Every single person's thing will be connected, so that national security is taken. But it's a major challenge that everybody faces. Having everything in a central database is very difficult. Every police agency will have their own software. State government of Tamil Nadu will have their own software, their own method. Kerala government will have a different method, a different software. Intelligence Bureau in Delhi will have a different software and hardware. So all these have to be connected so that law and order situation can be improved. So it's a major challenge that India is facing. But of course, the government is now working towards this national intelligence grid. More or less, there is an integration now, but still things have to come. So that is all from my side today. Let me take the attendance. You can stop the recording. I don't know why in between it got stuck. Yeah. So I want to